One of the things that we see at SunLink from the technology side is that even with the best performance guarantee, if the data isn't telling you what your project is really doing, if it's not insightful, if it's not giving the team that's both on the ground as well as the monitoring team who may be remote really actionable intelligence that you can go out and do something with, then you kind of get into this battle, which I think is what you're alluding to. Whose responsibility is it to go out and fix something that's going wrong on site, or is something going wrong on site? Is it actually just more of a soil condition or something strange that's more of a local event that's happening? So I think from our side, where we really focus is not necessarily more data, but better data, and getting that into the hands of people who can take action on it and really do something impactful, and having the priority be at the design stage of the project to make sure that that's what system is going into place. Then that's better for the life of the project than necessarily any kind of insurance package you can put on it. So in terms of measurements, I think coming from the side of being a tracker company, we take a little bit of a different perspective because we try to pull steel out of our system. We try to reduce the initial installed cost by relying on these measurements in the field. So we try to change our system from a passive system that really doesn't need any monitoring over the life to more of an active system that can take into account these measurements, the wind data, the snow accumulation, and dynamically move our system to account for that, to shed snow, to move out of the way of the wind, to be really responsive in real time. So for us, it's less about the raw data and whether this wind sensor says it's 35.6 miles per hour and this one says 33.2. It's more about what's the net impact to the system. So is your generation in terms of energy overall within the bounds of what you expect it to be? And then if it isn't, let's dive down into the details of why that is and be more transparent with what it is we're looking at on a particular project. But we really see measurements and different data being helpful for us in communicating out what is it that we're making decisions on a project and why. I agree with a lot of these comments. I think from the people who are trying to provide spare parts and to make sure that our long lead time items are never the holdup on projects, even things like where are they going to be stored on a project site? Is it going to be a place where they're kind of maintained properly as they're being stored in case they're needed? And I do agree. I think oftentimes the frustration will be something goes down and a change is needed in the equipment, just like a parts change, and the lead time can be really frustrating. Ideally from the perspective of how you're working through your project, you do have hands on it. You're looking at your project kind of in your planned maintenance at least a couple times a year, going out and looking at your modules, and hopefully the way that the technology providers have given you their data, they can do some kind of anticipation in terms of we're starting to see performance act a little bit out of whack. We should start planning for replacement of these parts because we've seen this historically. We should know enough about our systems to know historical trends on what data do we see that kind of starts our own red flags, saying that this particular component may need replaced within the next 8, 12, 20 weeks, and then that way we make sure to get everything lined up where it's not a failure, but it's an anticipated thing. And I think that can help both on uptime of availability of the equipment, as well as reducing the unplanned maintenance costs of rolling a truck during a strike or at a time when your team is strapped and you don't want to expend those resources. I would add to that from the tracker side, since we are involved in the early design stage and then also the handover when we get to commissioning and long-term monitoring of the tracker. One of the things that we've seen be really successful is pulling all that data in when you start at the PV-sys level. I mean, using map visualizations has been really successful, that you can see what your terrain is, what your topography is, how does that impact how you're going to be tracking, how does that impact your shading analysis, trying to bring some of that data into the PV-sys model and make that really transparent on the front end. One of the things we've seen that is really frustrating and less successful is the concept of on-prem SCADA systems where you don't have access to update the server software, that there's this kind of mismatch between security concerns and then really just regular maintenance of technology, that there's an expectation that whatever you deliver from a server perspective has that same 30-year life as your inverter or as your tracker, when really it's no one expects servers to last 30 years without like maintenance and patches and doing software upgrades. So that's been one of the less successful things when it comes to projects.